Hello everyone, my name is Prabsimar Kaur and in this video I'll be demonstrating my task 5.2c which focuses on changing light intensity using GUI. The main objective of this task was to design a graphical user interface, a GUI, on the Raspberry Pi that allows the user to control the brightness of multiple LEDs. This task demonstrates how we can combine hardware control, software interaction using Python, GPIO, and PWM. For the hardware setup, I have used a Raspberry Pi board, 3 LEDs, two 20 ohm resistors, and a breadboard using and I have also used jumper wires. Each LED anode is connected to separate GPIO, specifically 29, 31, and 33, while the cathodes are connected to the ground through the resistors. The Raspberry Pi generates PWM, that is pulse width modulation signals on these pins to control the light intensity. This setup allows each LED to receive a variable signal from the Raspberry Pi, changing its brightness depending on duty cycle applied. For the software part, I have used Python programming along with the tkinter library for the GUI and our RPI.gpi library to control the hardware pins. The program starts by setting the GPIO mode to board, configuring 3 pins as output. Then PWM is initialized at 100 Hz frequency for each LED, starting with a duty cycle of 0, meaning LEDs are initially off. GUI build is using tkinter. Inside GUI, there are 3 sliders, each labeled LED1, LED2, and LED3. When a slider is moved, it changes the duty cycle of the LED's PWM signal in real time. This instantly adjusts the brightness. For example, a value of 0 turns the LED off and 100 makes it fully bright. The GUI updates continuously when we close the window, and the code safely stops the PWM signals and cleans up the GPIO pins to avoid any hardware damage. Here you can see the system working. The tkinter window opens with 3 sliders. As I move the slider, the brightness of the corresponding LED changes immediately. For example, when I move the LED1 slider to 50, the LED glows half brightness. Increasing it to 100 makes it glow at full. Same happens for LED2 and LED3. This demonstrates real-time control of LED brightness directly from the graphical interface, showing how effectively the Raspberry Pi can handle both user input and PWM based upon output control. If I talk about the challenges I faced while working on this task, one of the main challenges I faced was syncing the tkinter GUI updates with PWM signal changes without delay. Initially, a brightness slight updates lagged slightly, but by refining the callback functions and optimizing the PWM signals, I achieved smooth real-time response. This task helped me understand how embedded systems combine software interaction, signal generation, and hardware control. To conclude, this project successfully demonstrates how to use a Raspberry Pi and Python GUI to control the brightness of multiple LEDs through PWM. Thank you